Hello, welcome to this new video. So in this video, we are going to have the look at a new topic called as Model Context Protocol or MCP. So if you have seen YouTube or other forums related to AI, you would know that this is the hot topic that is going around right now. So we'll just do a deep dive into what MCP really is and just help you set up an example of through code MCP and how it works and explain to you in the coding terms as well. So what is MCP? So MCP is nothing but a new open standard that was developed recently that aims to standardize how particularly LLMs interact with tools. So it is in a similar way how USB or why USB was developed in the first place, to again just to standardize a way of connecting between devices. And if you are again a front end developer, it is similar to how or why the REST API was developed. Now let us look at the main core concept or the idea behind development of this MCP protocol. So MCP again just allows us to standardize all the tools that we are going to develop into a single format, so that tools become a rather plug and play kind of scenario, rather than each tool following its own format, thereby making it difficult connect it to LLMs. Now, this next main reason was that if you have worked with LLMs, you would know that the more context or more instruction you give to the model, the better and better responses it generates. So, because we want LLM to generate the best possible result for any given scenario, we want it to take these tools into consideration and fetch all the information by itself. So that way we eliminate the entire process of user providing it additional context, or again even executing certain things using tools, etc., in a much more automated fashion, rather than user controlling and having to set up all the things on his own. So this was the core concept or idea behind with which MCP was developed. Then let us have a look at the main architecture of how MCP really works. So similar to how in a web application we have the front and back end, here we have a similar architecture of MCP clients and MCP servers. So MCP client in a way acts as the front end, where we pass on the connections to the MCP server. And just to give you an idea, a single MCP client will be able to connect to multiple MCP servers, each having its own server and tools, etc. And the MCP server, where the entire logic of how the tools needs to be defined, what it does, how it connects to any external sources, if it is going to connect like that, or if it is going to, let us say, perform an action on local computer, what all logic needs to be followed, etc., will be coded in the server side. So this is the architecture of MCP. Now let us have a look at the various transport mechanisms or communication between the client and the architecture. So we have two main communication that it particularly follows. One is the standard input-output format, where the client and the server run on the same machine. Thereby, we allow the communication happen locally. Then we have the HTTP plus server sent events format, where in which we allow these clients to be connected to servers through HTTP instead of running it locally in our machines. So this again allows us to set up servers for others as well, that they can use for themselves. So for example, if you see, we usually whenever we try function calling with LLM, we generally use a standard example of get weather function to get weather from any other weather API. So similarly, how this weather API helps us get the function details from their server. Similarly, MCP servers can be set up on their end that can be accessed by the LLMs. That way we do not rely on the function calling mechanism, but it acts as more of a tool to get the data for us. Then the main flow of the entire MCP architecture. First is the initialization part, where the host application starts. So it just create the MCP client and establish a connection with the MCP servers. Then the discovery. So let us say when the user queries that particular agent with anything, or that particular with anything, right? So first what the LLM does is that it knows what all tools it has access to, for it to clearly analyze and extract all the relevant information out of it. Then comes the context provisioning part, where the host application or the LLM makes use of these tools to fetch the relevant information. Then we have the invocation tool, where it actually uses the tool to fetch the information by actually running the tool. So in the context provision part, it just decide what tool it needs to use. Then in the execution stage, we will execute the tool and at the server end, and get all the data it needs to the client side. Then once it gets the data, it get added to the context of that particular LLM, and then it generates the response back to the client. So this is the entire flow of MCP. Now let us have a look at with a simple example of how you can set up an MCP client and server. So for this, we are going to use the OpenAI's new agent library that they have released, and we are specifically going to use the Python SDK to code the entire client and server in the Python. Now let us have a look at the code. So if you see here, the main thing which we are following when setting up the client and the server in Python is that so MCP again provides its own SDK package for Python for us to set up MCP servers. And when interacting with the agent, we are actually using a fast API application as the client side application that connects with the MCP server. So first, let us look at the MCP server code and how to set up the server. So for that, this particular example, what I'm going to do is that just set up a SQLite database and make this particular server tool connect to the database that and the tool which we are going to design is nothing but a simple select query we are going to perform based on the user information. So so after importing the SQLite and JSON, we import the fast MCP from the MCP SDK which we have. Again, to just install this MCP server, I will give you the link to the particular GitHub repo where you can find all the details regarding the installation of the MCP library. Now, after importing the fast MCP class, we are just going to set up that particular class and give it a name as SQLite database. So this kind of forms the name of that particular MCP server which we have set up. And the additional settings I'm going to run is that I want this MCP to run on port 8000. Next, we set up the or give the database file location, because again I'm just connecting to a local SQLite file. I'm just going to provide it the absolute path to that particular file. Again, if you want to connect to any Postgres SQL or even MySQL databases, you can accordingly modify the connection settings for that. So after defining the database file, we are just going to define the MCP tool here. So when defining the MCP tool, we just have to do mcp.tool at the start as a decorator, then define the main function. So in the function, I'm just going to query the products and I'm just going to accept name as a string here. Now, once I get the name as input, what I'm going to do is just establish a connection with the database. Then after establishing the connection, I'm going to execute a simple select statement where I'm looking for a similar kind of named products from the particular database. Then I'm going to say execute that particular statement, fetch all the results, convert it into a list, and pass it on as JSON format to the front end. And again, before exiting the particular function, I'm closing the connection as well. Now, after defining this particular tool at the end, within the main if main condition, we are going to run the MCP server and we are going to set the transport as SSE. So what this SSE transport will let us do is that it will run a simple fast API application when this particular tool is being called. So that way the entire data process transfer happens through http plus servers and events rather than the stdio format. Because again, locally if I show you the stdio format it will be helpful, but again if you want to set up your own public mcp servers, you need to know how to run it in the sse format as well. So with this we have pretty much set up the entire mcp server side. Now let us go to the Flask or the client side, where we can see how we can set up the client side for the MCP. So in the client side, if you see, it is a typical fast API application setup. So we are importing the required libraries to set up the fast API. Then we are going to import the libraries from the OpenAI's agent Python SDK that they have recently released. So from the agents, we are going to import the agent runner, generate tracer ID and the traces. So I will explain in detail when we go to this part. Then from the agents, I'm going to import the MCP server with the specific SSC connection. So why I specifically went with the OpenAI's agent SDK platform is that, or library is that they have now supporting the MCP formatted tools as well. So compared to other agentic platforms such as Autogen, they are yet to support the MCP tools as input to that particular agent. So since OpenAI already support, we are going with the OpenAI's agent library for this particular use case. Then we are setting up the fast api app. So we are just defining the fast api app, mounting the static folder and loading the jinga templates from that particular folder. Then now we define the main function of ask agent, where which we are going to call every time the user is going to ask input in that particular chatbot which we are planning to design, which is going to ideally act as a client side. Now in the ask agent function, if you see, we are looking for the server file which we want to run. And then what we are doing is that we are running that particular file using a command called as uv. So you will also have to install this particular uv library. Again, I will give you the link to that particular github repo and the document, so that you can have a complete go through and install it yourself. So we are going to run the server using the uv command, and in order to run it we are going to call the sub process, which essentially is nothing but it runs whatever commands we are writing in terminal through python. So we are just opening the terminal and running the command uv run and the server file which we want to run. So once the server file runs, again we are just waiting for 3 seconds just to make sure the server file is up and running. Then once the server file is up and running, we call the MCP server SSC format from the OpenAI's SDK, agent SDK, and set up the name for this particular server and the URL which it needs to look at. Now, after setting up the MCP server, OpenAI provides something called as tracing. So, let us say you create an agent, right? So, we need to essentially know what steps that particular agent is taking. And in order to monitor that, OpenAI provides a new service called as traces, which we can connect agents with. That helps us monitor what each step that agent is taking and what time, how much time it took to execute, etc. in the OpenAI's platform. So we are just entering the MCP server, and with this MCP server.a enter, we are just making sure that the MCP server is again up and running and we are able to access it. Now we generated trace ID. So what this generate trace ID will do is that it will generate a new unique trace ID. So it is similar to how a UUID, a string or a number which we are going to generate, and then give it to us. That helps us locate this particular agent in the traces in the OpenAI's platform. Now with traces as open, we are going to execute the agent. And in the agent, we are going to provide it just a name, the instruction it needs to follow. It is nothing but the system prompt which you are going to design, and the MCP servers it is going to have access to. Because we are just again setting up one MCP server, we are just loading this MCP server here. And in the model setting for the particular agent, we are giving it the tool choices required. So this what basically does is that lets the LLM know that it has access to tool and it needs to choose a tool, basically, before again proceeding with answering that particular user's client. Again, this is just an additional check to ensure LLM considers the option of using the tool before answering any particular user query. Then we just use the runner to run that particular agent and whatever user question we are going to have, and return the final output. And once we again execute this entire thing, we make sure we exit from the MCP server and the entire process is terminated, so that it kind of uses only when the tool is required, and the tool need not be running always. Then we have defined the basic base route, where we are just going to pass on the index.html. That is nothing but a simple chatbot which I have designed in the front end. Then we are going to have the ask route, where we are going to pass in the question from the user, call the ask agent, and then process the output and display the output back in the chat box. So this is the entire flow which we have defined. Now let us have a look at the chatbot and see how the chatbot really works, and how it uses the tool. Now let us have a look at the chatbot which we have defined, that is going to again interact with the client, and then the server, and get us the details from the database. So let us have in this particular again use case, design the e-commerce product assistant. So I'm just going to ask what are all the items available in this particular site. So if you see here, now it is going to trigger the MCP client, and that client instead is going to trigger the server side if it requires the usage of tools, and fetch the information from the database, and get it or give it back to us. So if you see here, it returned all the results in the particular database. So again, if you've seen our previous videos of using the chatbot, using SQLite tools, um, in the LangChain library, there is always this limitation of number of items we can fetch from the database at that particular time. But because these particular MCP tools are designed that way, it gives more the LLM uh, the power to control the tools, rather than the user predefining the tools and the restrictions for it. So if you see here, it is able to fetch all the information, not just the top 5 top 10 information from the database, but all the information from this particular database. Now let us say if I want to more know about the product beanie, or the scarf, let us say. So I'm just going to ask what is the scarf stock that is left. So again, it's already visible to us, it is 70, but we are just checking whether it is able to fetch that information or not. Yes. So it's specifically able to fetch the specific product information as well. Um, so I'm going to ask it a very generic question, and let us see how the uh, agent or the model responds with the help of MCP tool. So what I've again asked is that what clothing item you have that is suitable for the winter seasons. So let us say if we are able, it is able to figure it out, and uh, use the tool and fetch the relevant information from that particular tool. So if you see here, the jackets it is able to fetch, sweaters it is able to fetch. So if you so that way we can see that it is able to understand the context of the user, fetch only the relevant information from the database by accessing the tool that is connected through the MCP uh, server architecture, and then execute the tool and fetch the information. So this is a very good example to again demonstrate how to set up the client server and interaction, and again how you can integrate that potentially within the web applications that you've already developed so far. um, so hope this particular video gave you a very good idea of how the MCP works, how to set up everything, etc. So if you have any doubts, again feel free to contact us at contact@codersarts.com, or else you can reach out through our comment section as well, or through any of our social as well. Again, so if you want to develop such MCP client or servers for your own database or data source, or if you want your AI application to connect to such services, feel free to reach out to us, because we can develop MVP or proof of concepts for you to test it out, and then again build the entire production based application as well. So that's it for this particular video. So I will see you in the next video. Bye.